effect. Well, consider sodium atom. There are 11 protons and 11 electrons in it. We know that due to positive protons, nucleus exert inward force on the electrons called nuclear attraction. There are 2 electrons in the first shell, there are 8 electrons in the second shell, and there is only 1 electron in the third shell. The electrons in the first and second shells are called core electrons or inner electrons, while the electron or electrons in the last shell is called outermost electron. Now consider umbrella. We know that umbrella shields us against the rain or sunlight, and we do not receive the raindrops or very little sunlight. Similarly, these inner electrons or core electrons shields or screen the outermost electron from nuclear force, and it receives very little nuclear attraction. As a result, this outermost electron move away and revolve around the nucleus at a suitable position. Thus we say that shielding effect means when the inner electrons shield the outermost electron from the nuclear force. Also, we can define shielding effect as the inner electrons shield the outermost electrons from the nuclear force and reduce the nuclear hold on them. This effect is called shielding effect or screening effect. Secondly, we can also define shielding effect on the basis of Coulomb's law. Coulomb Baba states that there is attraction force between proton and electron because these both are charged particles. Let the distance between them is r1. Consider another proton and electron. There is also attraction force between them. Let the distance between them is r2. According to Coulomb Baba, there is less attraction force between this proton and electron because the distance r1 is greater between them, while there is more attraction force between this proton and electron because the distance r2 is smaller between them. Therefore, in the light of Coulomb's law, we can say that outermost electron experiences less nuclear force because they are usually away from the nucleus, while the electrons in the first shell experiences highest nuclear force because they are near the nucleus. Now let me teach you trends of shielding effect in the periodic table, like shielding effect across the period or why shielding effect remains constant from left to right in the period. Well, consider the second period elements like lithium, beryllium, oxygen and fluorine. There are 2 shells in the lithium, 2 shells in the beryllium, 2 shells in the oxygen and 2 shells in the fluorine. Thus the number of shells remain constant from left to right in the period. The valence electron are round about its same distance from the nucleus. According to Coulomb Baba, these outermost electron experiences almost same nuclear force. Although the atomic number increases across the period, but the number of shells remains constant, which dominate the increasing atomic number. The shielding effect remains constant across the period. Therefore, remember that shielding effect remains constant from left to right across the periods. Finally, shielding effect in the group or why shielding effect increases from top to bottom in the groups. Well, consider first group elements like hydrogen, lithium and sodium. We can see that down the group, number of shells increases. For example, hydrogen has 1 shell, lithium has 2 shells and sodium has 3 shells. So more inner electrons mean more shielding effect. So shielding effect increases.